Okay, today we have 5.6. We are going to be continuing solving quadratics by completing the square. But if you notice today on the problems, there is a number in front of our leading coefficient. When you are completing the square, you cannot have a number in front. So there are two options. The first option is the easiest, which is you want to check to see if all of these numbers are divisible by your leading coefficient, in this case 3, then you want to divide everything by 3. So the first thing you want to do is check if it is possible to divide out the leading coefficient. So in this case, are all of the numbers divisible by 3? Yes, so what we do is we would divide every single term by 3, which makes the 3 go away. I'm not factoring it out, I'm dividing everything by 3. So I'm just reducing, basically. When I go through there and I reduce, I get x squared plus 4x minus 6 equals 0. If you ended up with a fraction and it didn't work, then you couldn't do it this way. Okay? So now we're just going to complete the square like we did on our other problems. So who remembers the next step we're going to do here in order to complete the square? Very good. We're going to add 6 to both sides. Okay? So I add 6, and when I write this as x squared plus 4x, and then what? Plus blank equals 6 plus blank. Because whatever we add to one side, we have to be fair and also add it to the other side. That is why we have the 2 blanks. Who remembers now what our step is? Good. We always take that middle term, which is 4, divided by 2, which is 2. And then we take that number and we square it. And what is 2 squared? So 4, it is what is going in each of my blanks. You always take this number right here, 4, and you always divide it by 2. You're always taking half of it. 4 divided by 2 is 2, and then you, whatever that number is, you square it, which goes in each of those blanks. Now, how do I write this? The whole purpose is to write this as a square. So how is this written as a square? X plus 2 squared is correct. And remember that this number right here is always whatever my half number was. So whatever half of your middle number is, that's the number that goes in for your square. And then 6 plus 4 is 10. And now that you have your square, we can solve it, right? What do I do to solve? Good. We take the square root of both sides. Anytime I take the square root, my answer is going to be plus or minus. So we have plus or minus root 10. Can I simplify root 10? No. So we leave it like that. So I don't need to write 2 equations. Go ahead. Yes. And then the last thing is to subtract 2. So we end up with x equals, and how will I write that? Okay. All right, so are there things I need to go back and re-explain on this first example? So, yeah.
Why can't you simplify root 10?
Well, if you break root 10 down, it's 2 times 5, right? And is there any pairs? No. So, good question. So to recap, the first thing you're going to check for is what? Right, check to see if there's a GCF, that you could divide everything by that leading coefficient. If you can, and you get rid of that leading coefficient, that's great, because then we can just complete the square. Okay? So, if we go down now to number 2, on this one, my leading coefficient is what? 5. Can 5 go into all those terms? So I can't do that. Okay? So this is what you're going to do. The first thing you're going to do is move your 14. Okay? So I'm going to subtract 14. And we have 5x squared plus 15x. I'm going to go ahead and write my plus blank, okay? Equals negative 14, and then I'm going to have plus a blank. Now to complete the square, I can't have that number in front. But now that I have this 14 on the other side, could I factor out of 5? Okay, so we're going to factor out of 5. So I have 5, which will then become x squared plus what? 3x plus blank equals, now this is where you have to be careful, and I have negative 14. Now do you see how a 5, I factored a 5 from my blank. So since if you were to re-multiply this out, this would be 5 times the blank, right? So over on this side, we need to have what? 5 times the blank. So I'm going to have plus 5 times the blank. So that's the one thing you need to remember is that if you factor a number and you have a number outside of this parenthesis, you need to have a number outside of this blank as well. Because you have to be fair, right? And again, if I were to multiply this through, I would end up saying 5 times x squared, 5 times 3x, 5 times my blank. So since I have 5 times my blank on this side, I need 5 times my blank on that side. So if I'd taken out a 2, I would have had a 2 there, right? Okay. I forgot to change this on yours. I'm sorry, because this didn't work out right. It'll work out nice in your homework. So what we're going to do is go backwards just a little bit. Change this to 20 real quick, which makes this a 20. And then that would make this a 4x. My apologies. Everybody get that? Okay, so now how will I finish completing the square? Good. We take 4 divided by 2, which is 2. And then 2 squared is 4. So 4 goes into each of my blanks. So now when I write my square, how am I going to write it? 5 parenthesis. Very good. X plus 2 squared equals. Over here I have a negative 14, and then 5 times 4 is 20. So what is negative 14 and 20? Positive 6, right? Okay. Is the square by itself? No. So what are we going to have to do? Good. Divide by 5 to both sides. So now I have x plus 2 squared equals 6 over 5. Is the square by itself? Now. So what do I do? Good. We're going to take the square root of both sides. Okay, when I do that, I get x plus 2 equals, whenever I make the square root, it's going to be what? Plus or minus. And then I'd split this up. This is root 6 over root 5. And what can't I have? So how do I get rid of that root 5 on the bottom? Good. So we multiply by root 5 to the top and the bottom. So we have a pair of 5s. So I still have x plus 2 equals plus or minus. And what's going to be in the denominator? 5. If I break down the 6, are there going to be any pairs that I can take out with that? No. So we multiply the insides together, and 6 times 5 is? Zane. 6 times 5 is what? 30. Okay. Is my x by itself?
No.
No. Do you think I need to write this as 2 equations? No, because I'm not going to be able to add like the root 5 with 2 or negative 2. So all we're going to do is go ahead and subtract 2 over here. And so we get x equals negative 2 plus or minus root 30 over 5. And that's your answer. Okay, so to go back to the beginning, if I wasn't able to divide everything, oh, sorry, Mitchell, yes.
Couldn't you reduce the squares of 30 to 5 and 3, and then we'll cut
Well, even if you broke it down, I understand what you're saying. Like if you did 3 and 10, you're not going to end up getting any pairs. So remember that with roots, you can reduce insides of roots with insides of roots, but then whole numbers with whole numbers, the numbers in front. So there isn't a number in front that we could pull out that we could reduce by. Are we good there? Okay. So back to the beginning. If we cannot divide every number by the coefficient, what do we end up doing? So since all the numbers weren't divisible by 5, what did we do? We set it up as completing the square, and then we divided, we factored out the 5, right? Mm-hmm. Because you never want a number in front of your x squared when we are completing the square. Okay? All right. Do you guys have questions still on example 2? All right, example 3. How do you find area? Length times width. So if I write this out, I have x times x plus 8, and it tells you that the area is what? 40. Okay, so equals 40. What do you think you're going to do now in order to solve for x? Distribute. So if we distribute and we multiply through, I get x squared plus 8x equals 40. And since we're talking about completing the square, how would I finish this to complete the square? The 40 is already over on this side, which is good. So we just need to add our blanks in, right? So we have x squared plus 8x plus blank equals 40 plus blank. And can you guys finish completing the square here? Okay, so I'm going to give you a minute to try this on your own. Okay, so at this point, thank you. We have to stop and continue.